Now, welcome to the microwave course. We need to conduct few MCQs about this microstrip and a antenna there. So we start here with the first question. You can chart in a chart here the answer. A planar transmission line is a that is a two conductor transmission line. Then B uniplanar transmission line. Then C non-planar transmission line, and D one conductor transmission line. Now you type your message, your answer in a chat. Someone has to start the answer in the chat here. A planar transmission line is a two conductor transmission line, uniplanar transmission line, non-planar transmission line, or one conductor transmission line. That is about our question one. Okay, now that answer is B. No, it is about a two conductor planar transmission line. It is about a two conductor transmission line. Thank you. Next question. A strip line structure supports a only TM, only T, only TM, and D, T, TM, and TM mode. Please answer for this. It is about A. Okay, so someone says A here. So that answer is about the D, that it supports a T, TM, and a TM mode there. So next, it is about the D here. In slot line structure, propagation is almost a T mode with the cutoff frequency TM mode with the cutoff frequency C T mode with no cutoff frequency, then a TM mode with no cutoff frequency. What is the answer for this? 37. So please write your answer in a chat, then we will continue. Okay. Someone says it is B. The answer for this, it is about a T mode with a no cutoff frequency. So now next, an omnidirectional antenna is a parabolic dish that is dipole, then horn, then Yagi Buddha antenna. What is the answer for this omnidirectional antenna? Or we can say that is about the radiation pattern is about a omnidirectional one. Omnidirectional means what? Radiate the power in all the direction in one plane. Answer is B. Right? Correct? That answer is B. It is correct. It radiates the signal in all direction in one plane. Then suppose it is about a dipole antenna. The radiation pattern for this dipole antenna that's about a donut shape here. Or we can say that is about a pattern will be likewise. So it will radiate the signal in all direction in one plane. Next, radiation pattern of horn antenna is unidirectional, B. Bidirectional, C. Omnidirectional, sorry, and say none of the above. What is the answer for this? Yes, it is about A, correct. It is about a unidirectional radiation pattern. Since we have the horn antenna, it looks like there is about horn radiation pattern will be a unidirectional one. Okay, so that's why we say it is about a unidirectional radiation pattern. Bidirectional radiation pattern means this one is a radiation pattern that is about a bidirectional one. Omnidirectional is just like a circular, like a dipole there. So we can say that the about a omnidirectional radiation pattern there. If parabolic dish diameter increases, a beam width becomes small, becomes high, beam width high, and sometimes small. Beam width remains constant. What is the answer for this? If the parabolic dish antenna is there, okay, if there will be parabolic dish antenna, then what will happen to the radiation pattern for this antenna then? Okay, so what will happen? That there was someone says it's about a B here. No, that's about the beam width will becomes a small there because a antenna radiation this one is about a parabola there. If the diameter increases, so then naturally your radiation pattern will be very small. If diameter is smaller, so radiation pattern will be likewise. Again is smaller, okay. So that's about diameter increase smaller, so likewise. If it is larger, so then this one. Okay, so radiation pattern changes. So based on that, what will be the size or aperture area of that antenna? So according to that, irradiation pattern of an antenna changes there. Okay, so now next we continue here. Which of the following type does antenna belong? wire antenna, array antenna, aperture antenna, lens antenna. Which of the following type does horn antenna belongs to the? Okay, someone says it is about a 44, that's a 60 now. Yes, it is correct. Horn antenna belongs to the aperture because it has the apertures there. We have seen that. So this is about a horn antenna there. So we have seen likewise it's about the aperture of the sun. So this is about your aperture of horn antenna. So wire antenna means a dipole. Okay, we have a dipole is nothing but wire antenna. And a array antenna means what? There will be a n number of dipoles or n number of patch in a microstrip there. So the answer that is a aperture antenna. It is correct one. Then which of the following antenna is mainly used? Marconi antenna. Marconi antenna is nothing but a dipole antenna. Okay. So the but the length is a lambda by 4. Okay. Then a horn antenna, then a dipole antenna, then we say a wire antenna. So we have the antennas there. E, yeah, give that. Okay. So what is the answer for this? Answer is a B now. Right? It is about the B. So why it is used? Because we are using this type of an antenna for all of the purpose there. Okay. So it the range of the frequency is higher for this horn antenna. If you consider that a Marconi antenna, it is about a lambda by. Means what we have the antenna there and image is there. So that will be the total length is about a lambda by 2. Dipole, we can consider that about lambda by 2. Wire antenna is nothing but dipole. Yaguda antenna is part of a dipole, but it is a array one. So this one antenna used for the higher frequency. Wait a minute. Then one of the advantage of the microstrip antenna compared to conventional microwave antenna. A, small size. B, low gain. C, low surface excitation. And a high gain. Okay. What is the answer for this? Answer is about a. That is about a small size. Yes, correct. Because it is about microstrip antenna. It is small size, low weight antenna. So that's why it is about it. Correct. Okay. The next, in mobile, which of the following antenna is widely used? A. Microstrip antenna. B. Horn antenna. C. Yagiuda antenna. And D. Lens antenna. Okay, correct. It is about a microstrip antenna. It is used in a mobile phone. Why it is used in a matter of this one in a microstrip? Because it is about a lightweight. If you consider the horn antenna, so it is that weight is high, so that's why it is not used. Okay, so microstrip antenna mostly in a mobile phone, you can see that this type of antennas are used. Okay, then the small flare angle dash dash is the directivity and dash dash is the beam width. Think over it. Okay, it is flare angle that is in a horn antenna. So mostly flare angle word it is in a horn antenna. So what will be the directivity and what will be the beam width there? So answer is about low, high, high, low, 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 high, high. Now tell me the answer for this. The small the flare angle, what will be the yes, what is the answer for this? The small flare angle is the high directivity and a low beam width. If directivity is higher, then beam width will be a lower there. So just you just remember that the answer for this. Okay, so we can say that is about high. So answer is about a B is a correct one. So next question. Which of the following doesn't opportunity for fall flaring? Okay, sorry. Okay, that is flaring in a horn. Okay, so now option is about improve gain, B impedance matching, C decreases side lobes, and D improve standing well. Okay, which of the following, if we say that it's about a horn antenna we are using, so what will happen for this particular flare angles and all? So what happened to this particular flare angle? Please type your answer there. Okay, so someone says B, impedance matching. Okay, no. Gain is there because flare angle, if we change the flare angle, gain will be improve, okay, or decrease is there. Even it will be better for the impedance matching. Again, it will be better for the side lobes. Side lobes are not there. Okay, so that's why we can just say that it improves the standing waves there. Okay, that is about the answer for this particular question. Again, question whatever I am writing, that already I have answered to this. Okay, in horn antenna, impedance matching is provided by layering, increasing power, decreasing axial length, then a balloon. Please tell the answer for this. Yes, correct. It is about A. It is about a flaring there. So that's why I told you. We have given the answer earlier. Okay. Next, in horn antenna with increase in aperture, the directivity is dash dash and diffraction. It is dash dash. Answer increased, comma decreased, B decreased, comma increased, C increased, comma increased, D decreased, comma decreased. What is the answer for this? Sir, in last question there was, okay, so we'll ask you. Now the answer is about the B there. Okay. So now the in horn antenna with increase in the aperture size of the horn antenna, then directivity will be increases. Okay, size of the aperture increases, the directivity increases. And what about the diffraction? Diffraction is decreases there. So the answer is correct. Okay, so because it is increases, the directivity of an antenna increases. So that's why the diffraction is decreases. The next one, in which of following bands the horn antenna operates? A, HF and VHF, B, UHF and LF, C, UHF and SHF, and D, LF and VHF. Which band this horn antenna operates? Yes, please type your answer for this. The higher frequency, ultra high frequency. So the operation of this particular antenna, okay, horn antenna, it is at a higher frequency in terms of a gigahertz there. So that's why we can say that about the UHF and a SHF band. Next, which of the following wave conversion mechanism is performed in parabolic reflector? A. Plane to spherical, then B. Spherical to plane, then perform both. Okay, perform both means what? Plane to spherical and spherical to plane. Both A and both B. Okay, so then D. Elliptical polarization. Please answer for this question. So what will happen to the parabolic reflector? Okay, so whether it will perform the plane to spherical or spherical to plane there, or it will perform both plane to spherical and spherical to plane. Okay, both, or it will perform with the elliptical polarization. So the answer for this will perform a spherical to plane there. Now with this we can consider that